Welcome to The Machine, a computer science education podcast from Waterford Institute of Technology. My name is Rob O'Connor. I am a lecturer in the Department of Computing and Mathematics. Today we are going to carry on our conversation about the subtopics inside the general topic of computer science. We're looking at some of the areas that we specialise in at WIT. Today we're going to discuss the Internet of Things, and in the actual studio, which I'm very excited about, we have the stream leader of Internet of Things, IoT, Frank Walsh. How are you, Frank?
I'm doing fine, Rob. How are you?
I'm good. I'm very good. All the better for seeing you and having a cup of coffee beforehand.
It's nice to be here in person.
It is actually,
Absolutely.
Yeah. And we also have third year student who is taking IoT, Dominik Wawak. Now, did I pronounce that correctly?
That's correct. That's perfect.
Thank you. I didn't want to insult you right at the start of the podcast, so that wouldn't, we get off on the right foot. As always, the housekeeping thing at machine_podcast on Twitter, Machine Podcast on Facebook, subscribe on Apple Podcasts, Spotify, blah, blah, blah. Leave us a review. That'd be lovely. Right. Let's start off with a very simple question, but it might take us a little while to answer. Frank, what is the Internet of Things?
So, the Internet of Things, I guess, is all about connecting everyday devices or objects, the things, to the Internet and allowing them to send and receive data. So, to put it in another way, it's about connecting your stuff, your ordinary stuff, to the Internet. And once it gets connected to the Internet, then we can do a whole load of new stuff with it. So, I could give you an example of what I'm talking about. Let's just think about a doorbell, right? Yeah. So everybody at their house or at their apartment, they have a doorbell and somebody rings on it and it makes a noise in the house and they can come and answer it. Now, what you can do these days is you can buy what's called a smart doorbell, all right? Ring, it's called. You can go out to Harvey Norman out the road and buy one of those. That's connected. You take that home, you can connect it to your Wi-Fi network. And all of a sudden now, you can use an app on your phone, which comes with the product. And you can, if you're out of your house, somebody rings a doorbell, you'll know about it because you'll get a notification on your phone. What's more, it has a camera on it so you can see who's actually at your front door and you can talk to them as well. So that's an example of an Internet of Things thing, so to speak. It's an everyday thing like a doorbell connected to the Internet.
Now, I'm going to play devil's advocate throughout this conversation, just to, I suppose, to maybe always to bring it back. If I was of a paranoid disposition, I might think that this all sounds like very much like you want to put me under surveillance. How would you feel about that? Why would I want to do this? Is my good old fashioned doorbell not good enough?
Well, it is if you're in your house. But in this, in these days, a lot of the times you're out of your house. You might be working. You might be at college. And another thing is that a lot of us now are using online services. We're ordering our stuff from Amazon. We're ordering our stuff from Boohoo. This stuff gets delivered. If you're not at home, what do you do? How do you deal with that? Now you have a way of dealing with it. You can talk to the delivery person. You can tell them, look, could you drop that next door? Or did you do this with it or that with it? Right?
Yeah.
That kind of thing. So, to me, I suppose there is a chance that you think, you're under surveillance. But, I guess, and another thing about the Internet of Things is that it's all about making our lives easier. Right, making in the modern age, in the digital age, it makes things easier. It makes things more efficient. It means that I don't have, if somebody calls to my house, if I'm not there, I can talk with them and I can tell them when to call back. All right, so that I'm not wasting fuel, say, going to a depot to pick up my parcel that I've missed delivery for.
Yes,
right. I can talk to the delivery man and say, look, I'll come back now, just if you hold on there for a minute, I'm just down the shops or something. I'll be back in a sec. I can take it off you. So it's about helping people, really, I think, So, yes, there is that aspect of it that you might think it's surveillance, but more so, I think these technologies help us have easier, more efficient and productive lives, I think.
Dominik, so you're in third year of your bachelor's degree, so you're kind of past the halfway point. You're still a Padawan on the path to nerd Jedi Knightdom. Okay, I should have really thought that through. What was it that attracted you to IoT, Internet of Things?
I think it's a very good question because I remember picking the stream, and first I was kind of decided on forensics, and then I was like, oh, IoT, it sounded funny to me. I didn't know what it was. And then I was looking on the internet, kind of, and on the description on the site. And I was like, oh, something to do with devices. And I think I had a very kind of hardware, kind of practical, hands-on aspect, a kind of skill that I wanted to kind of pursue more.
Yes.
And I think that pushed me kind of to choosing IoT first because of this hands-on, the software talking to hardware, and that communication kind of writing something in code and then seeing, let's say, an LED blink or something kind of puts a smile on your face. At the first, I think I did a lab with you, Rob, in first year.
Oh, in computer systems, the Blinky Lab. Yeah.
And I think that was really cool.
So we'll just explain with the Blinky Lab. We connect up a Raspberry Pi, which is a very small computer, to a simple breadboard circuit that I think it just has an LED and a resistor on it. It's like one of the most simplest circuits you can build. And I
think it was a Twitter API that we used, and
yes, we connected it to Twitter so that if a hashtag is the light goes off.
Yes.
Well, that's the kind of groundbreaking stuff we do here in WIT. So if hashtag, I think it was hashtag Waterford. I think hashtag Waterford, a light goes off.
Brilliant.
and you'd be amazed how infrequently that light goes off. But I know what you mean, though. It's that. So when I was in your position 100,000 years ago, there was this idea of the death of hardware, that we were moving away from computers as a physical thing. It was moving towards being a more abstract, software-based software. That the phrase was software will eat the world, but the hardware, we were kind of moving beyond that. Whereas with IoT, it's kind of turned that on its head, because we're back to physically mucking about with individual electronic components, even at a very low level and even at a higher level where they're maybe modular and putting those together. Yeah, but you obviously enjoyed that, did you? You got a buzz off it.
Yeah, I think it's like just puts a smile on your face, seeing something interact, or even like a motor moving on its own, or maybe like when you send something to it. It's a nice feeling.
Yeah, it is. So, what has been the biggest challenge for you as a student working in IoT so far? Now, it's maybe an unfair question. And feel free to speak freely as well, but because Frank and I are here, but this is, so you can cut the back office if you want. No problem with that.
Maybe some understanding some of the kind of the concepts in networking. That's probably a challenge.
Yeah.
But I think the more you work with it and the more kind of practical problems you try to solve, I think it kind of clicks. It clicks in the end.
Could you give me an example of a practical problem that you've solved besides making Twitter machine?
Practical problem.
Yeah.
So I kind of got a project. Or
it can be a project. So the kind of project that you might have worked on or something.
I think I was in the first semester of IoT, which is the second semester, first year. In IoT, we're given these projects, and we can choose whatever we want to work on. So IoT is all about solving like an everyday problem, problem solving basically. And I worked on a smart drawer. It was called Slidey.
Okay.
So it was a small drawer that when you dropped something into the drawer, it would send you a message on Telegram, bot. And it will send you a message, something's been put in the drawer, and when you take something out, something's been put out the drawer. So maybe it's for a conscious kind of security person. Someone has a drawer that locks. I also had a servo that would lock the drawer.
Okay.
So if someone let's say had some precious things in a safe, maybe a safe or something, and they wanted to know when that safe was opened, they can have a history of messages when something was put in or taken out.
Okay.
I remember that was really good. Yeah.
And so right now, I'm only just trying to tease this out because I don't know. So was it based on, there was obviously a trigger when you opened the drawer, there was some sort of mechanism that detected the drawer had been opened, yes?
There was a servo, which is a motor that can just set the angle to. And that servo opened with a text message. So you texted the bot open, it will open your drawer. Text it close, it will close the drawer.
Okay.
It would just lock it, basically.
And when something was put in the drawer, taken out, was there some sort of like pressure thing or a scales in there?
Yes, there was a load sensor, which
Okay.
is basically the thing used in the scales. So it detected the resistance based on whatever's put on it.
So you're describing a couple of very low-level hardware devices. I mean, essentially a motor, a lock, and a scales,
Yes.
A pressure sensor.
Yes.
And how then are those tied together into something that's, and I'm using air quotes here, smart?
Yeah, so those devices are just electrical components. They're not smart. So
Yeah.
you connect them to small computers or controllers, Raspberry Pis or Arduinos, and they take the data from these devices. They could be even temperature sensors and all this, and they push them to the cloud or to your phone or to whatever platform you want, pretty much. And you can manipulate that data. So you can take, as in my example, you can take the position of the servo, and if it's a certain position, you can say if it's open or closed. Or you can take a value from the load sensor and you can say, well, it changed. It was different than before. So if it's bigger, that means something was put inside. And that computing on the controller makes that device smart and interacts with the humans as well. So
you mentioned the Raspberry Pi. Could you just explain what that is?
Essentially, it's a small computer. It's a single board computer, so you don't have to connect any graphics cards or the processors on it. All the ports are on it, and you can use it as a normal computer, or you can use it to plug in smart controllers or
or individual components, like a pressure sensor. Yes. And the idea is that, so you mentioned that like the servo and the lock, they're thick. They're just devices. They don't have any intelligence. But what you can do is you can program the Raspberry Pi to act as the brain. It's a crude analogy for those devices, or to control those devices. And you can program the Pi, which then controls the devices, and that's what allows it to be smart. Is that fair?
Yes, that's fair. It gives us a human readable information for us, taken from the devices.
So what I like about that is that's a project I can understand. I can visualize what's going on there, and I can see the benefit of something like that. You know, I mean, I mentioned earlier, you know, possibly unfairly about surveillance when you were using the doorbell example. But, you know, I just kind of said I'd raise it up straight away. Frank, you have a very interesting story about a project that you've worked on yourself, which I'm fascinated by because it involves a couple of things that I'm interested in. One is beer. One is technology. It's like, it's got everything.
Well, I think I think you could say, beer has got me here. I mean, that's how I got into the Internet of Things. I like to brew my own beer. Okay. And I do it out in my garage at home. And at the time, we're going back a fair couple of years ago now, I won't say how many, but I was brewing beer out in my garage. I was fermenting my beer, you know, and when you ferment beer, you know, it's a good idea to keep it at a certain temperature. Okay, so I had a controller to do that, a standalone controller. So I can just set it. It's like a fridge. Think of it like you can set it at a temperature and said, right, and that was working away.
So is it 18 degrees or something? Isn't it?
It's exactly. Well, depending on the type of beer. We won't get...
Oh, yeah.
But we should do a beer podcast, but not now.
Yeah, we should actually. Yeah, that'd be great. But the reason I just...
That's right.
It is, because I remember I used to brew a bit of beer and I always made bags of it somehow, which... This is why I'm fascinated by your project. So you want to keep your brew around about 18 degrees because that's the optimal temperature where the yeasts are working with the sugars and
so you want to keep it bang on around between 18 and 20 degrees. So I came home one day and I said, I'll go out and have a look at what's going on. And when I opened up the fermentation chamber, which is kind of just a fridge really, you know, I opened it up, it was just full of foam and stuff and it was really hot. So what happened is my controller malfunctioned. It was just this kind of a thing that I had bought, but it was standalone.
It's like a little thermostat, really, was it?
Exactly. A thermostat. And it had malfunctioned. That was the end of my beer. You know, all my hard work down the drain, literally.
Yeah, because when you're brewing beer, it takes weeks.
Oh, yeah.
Yeah. It's not like, I put it in, I'll come back 2 hours later.
It's a big investment in time and I was really disappointed. But anyway... So, look, I'd been messing around with Raspberry Pis and a little bit with these things and computers. And, you know, I have a background in computing. So I decided I'm going to build something now so this will not happen again. So what I did is I got, Dominic mentioned already, I got a small little thing called an Arduino, which is a microcontroller. So think of that as like a small little computer.
Okay.
And I can attach sensors to it. Okay. So I got that, and I connected up a few temperature sensors to it, and I connected it to my fridge, right? So I can switch my fridge on and off. And I also connected it to a heater in the fridge as well. So I can switch that on and off. Okay. And also I got a temperature sensor, which I could stick in my beer.
Oh, okay.
So I programmed then, so like this, our little Arduino has these things connected to it, and then I can write a program that I can put on the Arduino, and what it does is that it monitors the temperature in the fridge where fermentation is taking place. If it gets too cold, it turns on the heater. If it gets too hot, it turns on the fridge. So it keeps it just at the right temperature. So I installed that in my fridge, but the key thing here is that I connected it to the internet. I connected it to the internet using a Raspberry Pi. So I connected it into a Raspberry Pi, and a Raspberry Pi, like Dominic said, is like any computer. So I can do stuff on it. So I can write programs on that too. So that was monitoring the Arduino and making sure it was doing what it was supposed to do. And then what it would allow me to do then remotely is that I wrote a little application for my phone that I could, at any time, anywhere, just have a look at what's going on in my fermentation at home with my beer. So I can make sure it was bang on the right temperature. But the key thing is that if a couple of things happened, if say it got too hot or too cold, it would send me a tweet immediately to say something's wrong. Or if it didn't hear from the Arduino, if communication broke down completely, as in there's no information coming out of that thing at all, as in like somebody plugged it out, again, I had another thing working in the cloud that was monitoring this, and it would tweet me as well.
Okay.
So this way, hopefully nothing. And since then, nothing like that has ever happened. So I built that myself. So I have it on my phone here. I have a little app, and I can take a look at it and see, right, at home the beer is at whatever degrees and it's been fermenting, and it has a little graph on it too. So I have all the data about my beer, and it's all being run by a little Arduino at home and a Raspberry Pi.
And has it resulted in better beer?
Yes.
Okay.
Well, that's what I tell myself.
Yeah.
But yes,
Yeah.
yes, it is, because I've been like that. Like that's the essence of the Internet of Things. Like you solve these problems, and then you keep on improving it. So you keep on adding value to it. So I have it now, so I can actually program temperature changes, because like if we do this podcast on beer, like as beer ferments, you might decide just before the end of fermentation, I want to push it up a couple of degrees to stop, to make the beer essentially the quality better.
Yes.
Or I might want to cold crash it. So right at the end, then I'll go from 18 down to 5 degrees really quick. So I can control that from my phone from anywhere.
Okay.
Or I can program it to do it at a certain time. So I've added these little bits on as time goes on.
So what that means is that you have a specific problem, okay, in your life. Which we always talk about problems and solutions. I don't mean I don't mean you have a beer problem, Frank. I don't mean that at all. But you had this thing you were trying to solve to be able to do a better job at it.
Yes.
And through the use of some what is relatively simple technology, but applied in a very innovative way, you were able to make better beer.
Yes, absolutely. And it's worth actually saying that the stuff I used to create this, your Raspberry Pi, your Arduino, these are quite accessible. They're reasonably cheap components. Yes. Anybody can buy them. If you go back, 30 years ago, and you were trying to buy something that had the power of a Raspberry Pi or something like an Arduino, if you wanted to buy those, you need a lot of money, And that's another thing that's driving the Internet of Things and has created the Internet of Things, is just the accessibility to both the hardware and the software to make it happen as well, and combining them together to create these kind of interesting solutions for things. So everything is connected and we can be more efficient, and all these kind of added value things that we have with the Internet of Things. Yeah,
like the Raspberry Pi, the board on its own, the Raspberry Pi 3, I think is £35. That's right. Ish. 35, I think sterling is the price. That's the board on its own. But then you have to buy a couple of extra bits to go with it, power supply and blah, blah, blah. Yeah. But it's still relatively cheap. Like we had a lot of the first years buying it, and I think they were buying Pi 3 kits with power supplies, SD cards, cables. I think they were €23, I think, ish. Now, some of them ended up paying a load more because they caught with a Brexit tax. But anyway, that's a whole other kettle of fish. And there is a Pi 4, which is a much more powerful
That's right.
device that you can go into 100, 150 with that, depending on which model you go. How much is an Arduino board?
Well, it depends. So the Arduino is something called, it's open source hardware. So anybody can make it. So if you buy an authentic Arduino, depending on, there's different types of them, but they start at around, I think about €5 for the real small one.
Okay.
Right? Up to the Mega, which is about the same price as a Raspberry Pi. So about $20, €30. Okay. But you can order Arduino boards. They're not official Arduinos, but you can order them, say, on Alibaba or, out on the internet. You can order them for about €3 or €4 each. Okay. So I know students that just buy lots of them.
Yeah.
And if they fail, or if they, blow them up or something.
Yeah.
You just take another one.
Yeah.
And this is fantastic because these are things you can program. You can get them to do all this amazing stuff like Dominik was talking about. You can essentially solve problems and create really interesting applications out of them and connect them to the internet, connect them to other services. Like as I said, my beer system, it tweets me, or I can get it if I'm not happy with that, I can get it to email me or, post a message on Slack or something, but I can access all these other, it all starts with the physical stuff, the hardware, something that's actually physically happening, my beer fermenting, and I can get that data and I can push it out to all these different really cool services, connect them to all these really cool services on the internet and make kind of interesting things happen.
So we'd often hear the term stack.
Yes.
In terms of computing.
Yes.
Right? In the context of what we're discussing here, could you maybe describe what a stack is?
A stack, so a technology stack you're talking about.
Yes, I'm talking about technology stack,
Okay.
as opposed to maybe a data structure stack. I don't mean like that. I mean
Yes.
but you'd hear full stack developer, an IoT stack, or if you're reading articles, you'll always see, the stack that they're using is quite innovative. What does that mean?
So I get what you mean. So IoT, the nature of IoT and the type of devices and what we're using, like as you said there, like with IoT, it starts with essentially the physical device. You could talk that's down the sensors and the physical device itself. And we talked about the microcontroller, the Arduino board, right?
Yeah. So the IoT, when we're talking about IoT, we're always talking about something that actually exists in the physical world.
Starts
always,
there.
And it could be a light bulb, it could be anything,
There
but
is
it's always
some
something.
interface there with the physical world,
Yes.
typically, right? So that's where you start there, and so you'll need the devices that are associated with that. They're going to use electronics. Okay, so you generally start down at that level, and they're working on what we would call a constrained device. So, like the Raspberry Pi, it's powerful enough, but it's not that powerful. And similarly, the Arduino is not that powerful. And usually they might be deployed in a place that's not very kind of connected, right? Like my garage, for instance, or they might be deployed like in agriculture. You might have sensors out in the field, out in various inaccessible areas. So as a consequence of that, they're in the technology stack for IoT. The devices themselves, they're not necessarily connected all the time, and they're also constrained, and they're mobile. So as well as having these small constrained devices, you need connectivity. So the connectivity typically then in that instance, if it's a commercial device, it's going to be Wi-Fi, or it might be something like Bluetooth low energy. Okay, or some other wireless technologies that are out there, something called low power wide area networks, and these are new types of wireless networks, kind of like your mobile phone network, but they're designed for connecting devices and exchanging data between different services and devices, in that might be very remote, So you have that connectivity there. So you'll have to have networking protocols or networking technology to do that, like wireless technologies, and also wired ones for ones at home. Yeah. Then, because these devices as well are producing a lot of data, when you get up, when they're connected, they need certain types of, I suppose, rules to allow them to exchange information. So you have specific, what we would call protocols in networking to allow them to do that. Okay. And because these devices, there might be lots of them there. When you move up then into the internet, the technology stack is very similar to what we would use in normal web development or in the web world. But there are what we call IoT platforms that allow us to take the data or information that these devices are producing and then do something interesting with it, either kind of analyze it, get analytics from it, process it, store it, that kind of thing. So these are IoT platforms, and they're specifically, and these are emerging all the time. Like there's lots of them out there. All the big like IT companies out there, like Cisco, Microsoft, Amazon, HP, they all have specific IoT platforms, and these are a stack of technologies that are specific. They're the best of breed for Internet of Things. So what they can do is it allows you to easily connect devices that you might have into them, get data from them, process that data, and make kind of interesting kind of decisions based on that data. For instance, if I'm working, I suppose if I'm working in a factory and I've got lots of different machines in that factory, if all those machines are connected, I can get all the data from those machines, bring it into an IoT platform, and then analyze it, maybe graph it, like show it up on a dashboard and find out like, oh, look, that machine is starting to kind of fail. And you can get the system, the IoT system, to do that and to figure that out for you using cloud platforms and stuff like that, and make decisions based on that and allow you to proactively fix it before it actually fails, that kind of stuff.
Yeah.
So that's the kind of stacks the stack is there. But it all starts with the physical, I think. The physical, and then other protocols. We don't want to get things like MQTT you would have covered. These are specific protocols, but they're designed for working with very small devices, very constrained devices, and allow them to exchange data very easily. And they might lose contact or not lose contact.
Yeah, and you with those devices, you're obviously very concerned with power efficiency as well, as in electrical efficiency, and which is a whole other kettle of fish. Which is why IoT is often said to be a kind of a bridge between electronic engineering and computing.
Yes,
or it kind of has a foot in both camps.
That's right.
And depending on, and I know you work a lot with the engineering department here in WIT on the course, but it depends on where you're looking. So Dominik, the things you've described, you're very much looking at the applications, whereas you might potentially, say for example, next year you might need a specific component, and you might team up with an engineering student who might build the actual component, because I don't know, are you any good at soldering? I'm not.
We actually do. The IoT stream does a module that's paired up with electronic engineers.
Yes.
And that was probably one of my favorite modules as well. We did we made a microcontroller from scratch.
Wow.
So down from drawing a CAD drawing, which is just a drawing of the electrical paths on a little board, to sending it off to China, getting it printed basically, and soldering all the components on. So kind of putting that all together and then seeing a little response on a screen is just a big wow factor.
Yeah. So you described, before we came in we had a cup of coffee, and you described a project you worked on last year, which was Corner Spotter.
Yes.
So this is tied up with cars, is it?
Yes, more kind of like automotive as well.
Okay, so describe what that is, if you don't mind.
So maybe I'll describe the problem first. So let's say you're driving in the country, on a country road. The road is narrow, probably just fits one car. There's a tight corner, and you don't know what's around that corner. There could be an accident around that corner. There could be someone walking the dog. There could be someone. There could be just someone taking a walk with their kids or something. And I wanted a solution for this. So basically, a car would know if there's a hazard on the other side of on the other side of the road or the other side of the corner. So this project was essentially two devices. One device was a beacon that would maybe be positioned on a pole or on a driveway or something like that, something around a dangerous bend, and would monitor the road. It'd have a camera, and the camera would be able to spot objects such as an animal, a dog, or a vehicle. And if there was a vehicle or a person in this frame of the camera, then that would send a little packet, or send data, basically a string, or text to a device that was in the car. They were both powered by Raspberry Pis, and that device in the car would basically warn the driver. So maybe it flashed an LED. My one did like a red LED if there's something on the other side of the road, and a green LED if it's okay to go.
Yeah.
And there's another problem with this was internet connection in the countryside. So this is also an issue with Internet of Things. There isn't always great internet connection. Frank mentioned low-powered area networks, which is Wi-Fi that spans, I think, great distances. However, you can't send a lot of data through it, so it doesn't have a lot of bandwidth. But I used radio waves. So with radio, you can communicate over really long distances. And, well, you have to connect the device to the internet. So the device in the car, when it was connected into the internet, it would send the data to the cloud. And because of this, the data in the cloud, the application would be that someone will be able to monitor that data. So let's say this road is busy at 3 p.m. Every day. So maybe someone who's watching this data could say, okay, maybe we have to put in traffic lights in this place, or a safe crossing for children in this space. Maybe it gets busy at this time of the day. Maybe there's slow sign at this time of the day.
Yeah. So what I'm hearing there is it's a very interesting, very practical problem, and you live in the countryside as well, yes. So I can understand where you're potentially coming from with this. So you're using a load of existing components. Now, this is just a student project as well. This is just something that you're doing as part of a kind of a module, and you're looking at a real world solution to something that exists in your locality.
Yes.
And okay, we're talking, how would you get it into a car? It's a proof of concept thing. But, I can think of an example. I changed my car a couple of years ago, and it has the Google Maps and all that kind of thing in it now. And what I like, it's a couple of times, I haven't been to Dublin too many times in the last while due to pandemic, but a couple of times where I was up there, and it pops up a little red thing on the map to show that, the traffic is really bad in this area. Here's an alternative route. And to me, that's amazing because I'm not getting stuck in a particular area. But that's an example of where this kind of, I'm going to say crowdsourced information coming from elsewhere is being reported back to the car. It's obviously there's a well-worn path with Google Maps, but something like this could potentially feed into another stack that might be adopted by car manufacturers to warn of hazards in an area like this, and you can kind of let your mind go off as to how that might be employed. Is that fair enough?
Yes.
Do you think that's fair enough? Yeah.
I like the proof of concept.
Yeah.
I think IoT is all about just having an idea and generating an idea and just trying to prove a concept.
Yeah. And the worst that'll happen is it doesn't work.
Yeah.
Yeah. So for a lot of people, they may have kind of entry level IoT devices at home, like smart plugs or a smart light, like the Philips Hue lights or something like that. I played the guitar, and I recently bought some new kit. Now, I bought some old kit. It's old kit. It's not like a new year. It's a pedal board. I think it's about 5 years old, but it does have some connectivity with it. And what you can do, which for me, I think is quite cool, you can connect it up to an internet service, and you can download tones. So if you want to, do you know what? I'd love to have a tone that sounds exactly like Dave Gilmour's solo in Comfortably Numb, or whatever it might be, I want that kind of classic 60s fuzz sound, or whatever it might be, or a Jeff Buckley reverb drench guitar. And you can actually download it, and it will load all the settings onto this pedal board, so that you can just, with a click of your foot, you can get that tone on the guitar. Now, I don't know if that would typically be classed as an Internet of Things device, but to me it kind of is.
Oh yeah.
No,
to me that would be an Internet of Things. That that pedal, right?
Yeah.
That's a standalone thing.
Yeah.
But it's connected.
Yeah.
And once that happens, to me, in my book, it becomes an Internet of Things device, because it's connected to the internet. It's communicating with the internet, and you can. Essentially, you can control it, perhaps, in a way, from the internet. You can send that, you can organize so that it gets that data from some service on the internet, gets it onto the pedal, and then it uses it to do something, to actuate something, as in like play your music, whatever you want to do with it. So to me it is, anything like that in essence, like anything that is, is a physical thing, and like in my book, if it's not designed to be, originally connected, like a computer always had a keyboard and a mouse and a screen, right? But if it's something else, like, and then it's connected and it's not used in that manner for kind of a user to go off and kind of type stuff on it and things, and it's connected to the internet, it's an Internet of Things device.
Yeah. So, but we've described a number of projects. So you're talking about like little guitar thing. Now that's a product that I bought. I didn't build this. Okay.
Sure.
You've talked about your brew computer or your brew controller. You've talked about the corner splitter. You also talked about Slidey. Was it the smart drawer? They're all. I can really understand what those are.
Yeah.
Right. What would be if I wanted to learn a bit more about this? What would be the key skills I would need to actually work in this area?
Well, the first key, it's not really a skill, but like you described there, is this interest in it.
Okay, so curiosity, obviously.
Curiosity,
yes.
right? And that's the same with a lot of the stuff we do in IT, like a curiosity about how things work. Like, how can I do that, right? Beyond that then, and again, this is stuff we address in the stream too, like you need a kind of a range of skills, starting with, you need to kind of learn a little bit about devices. Hardware devices and how to program them. So microcontrollers is a good place to start. So we mentioned the Raspberry Pi and Arduino already. So things like that, right? How can I, what are they? How can I program them? The skills you need to program them, okay? And to interface with them and program them. A little bit of, again, if you're going to build stuff, right? And actually be kind of a maker, as we would call it, then a bit of knowledge around electronics and how electronics works, electronic components. So a bit about kind of electronics, electricity, and the different components that we can use, and how to connect to them and interface with them. So that's down at the physical level. You need to know how to program devices, so embedded programming, how to program devices. Now that in the last couple of years has become kind of easier. So we're used to, if I talk about programming languages, back 20, 30 years ago, if you wanted to program a device or a microcontroller, you had to do it using C. But now we've got a lot of different options. We can use Python. You might have heard of Python, the programming language. We can use Java. We can use, different programming languages to program these devices. So again, embedded programming is another skill that is good to know about this.
Which is really just programming.
It's really it's coding.
Yeah.
It's coding, and it's very transferable. So if you're learning coding conventionally using a computer, it's very much transferable into this space, right? Particularly in the last couple of years, it's with the tools that we've got for it. How computer networks, I think Dominik mentioned that, the networking, how computer networks work, and specifically wireless network protocols. That's very useful for IoT. It just tends to be that the devices, a lot of the devices, particularly consumer devices, they will be wireless. Like my watch in my hand here, that's an IoT device, right? That's monitoring my heart rate. Probably fairly high at the moment. Well, that's monitoring my heart rate, and it's relaying it to my phone. And then my phone has an app on it, and that's kind of connected to an app, another thing, up in the sky there that can monitor my vitals, as the day goes on. So Bluetooth, that's using Bluetooth. So knowledge of these protocols that we can use to connect to these devices in that manner, Bluetooth, Wi-Fi, and Dominik mentioned these other kind of ones that are specific to the protocol stack, the IoT protocol, the stack that you call it, things like low power wide area network type technologies like LoRa and Sigfox, just to mention ones. These are just wireless technologies that are in this space. So networking, and conventional networking, how computer networks work. Because if we're going to connect stuff to the internet, we got to know, if you need to know how these networks work. Wired people should know something about wires. That's what they say. And then programming skills and a knowledge of, again, I talked about these IoT platforms. These are generally deployed in what we call the cloud. These are kind of pre-built, best-of-breed technology stacks that allow you to kind of rapidly develop these, all these really interesting Internet of Things applications that are out there, like your like Ring, that doorbell, that smart doorbell I talked about, and lots of other products that are available commercially. They've got these platforms that they're developed using IoT platforms. So a knowledge of those and how they work, and how the technologies within them, so messaging, how we can exchange. So if I have a bunch of devices and they want to send a message to another bunch of devices, how do you do that? Like, and what are the technologies around it? IoT platforms have that messaging capability, so I can send a message from one device and it can be picked up by some service in the cloud and maybe relayed to another device, and that can be done reliably. So that's the kind of stuff you need to know.
And I suppose if somebody's here and God, I don't know anything about that, that's all it sounds like. The idea is that you learn it. You learn it along the way. It's not
absolutely.
Like you're expected to know this before you begin.
And the great thing about it is that there's a whole, I mean, if you go on the web and Google any of this stuff, like Google IoT platform or Google, there's a whole community out there working with it. And, the barrier to entry for it is not very high. You don't have to, you can start, we could sit down here with, if I had a Raspberry Pi and I could get it set up and connected and registered on what I call an IoT platform and get data from it, in 10, 15 minutes, it's that easy. Now, to take it further and to do really interesting...
I have a Raspberry. I'm holding up a Raspberry Pi.
We got 15 minutes.
No, we're not going to do a live coding demo.
Right,
I have a Raspberry Pi, but I don't have a power supply.
Yeah.
So
look, right. I mean, I talked about a lot of stuff, and you might be thinking, God, I could never get my head around all of that. But, the whole idea about these IoT platforms is that they're designed, all the different, providers of these platforms, they have their niche areas. But what they want to do is they want to let the likes of me and people out there use them very quickly. So they make them very user-friendly, I guess, very accessible. And particularly for ones that are designed for kind of the type of projects I was talking about. Now, if you want to go to like enterprise IoT or, industrial IoT, where it can get quite complex, but that's a different story. And that's the kind of stuff you would learn if you did the stream as well, as you get further up the years within the stream,
Yeah, but that's like it's just a natural progression moving
Absolutely.
on. That's all it is. Like,
Yeah,
but you start with simple things like building slide either or, which sounds kind of cool to me actually. Like, I can see where you're coming from with that.
Yeah, and you get to learn. It's worth mentioning too. I've mentioned a couple. It's quite multidisciplinary, and you get to learn a little bit about networking, a bit about coding, a bit about hardware, and you can combine that all together into one project. You're not just doing software, or you're not just doing networking. It combines it all together, and that to me makes it very interesting too.
Yeah, and I know like graduates of the course or people who have taken the course and moved on in their lives. They're working in areas like, I know before we were talking a lot of people working for car companies.
Correct.
Because that's obviously a massive area in the world of Internet of Things.
Yes.
People working in the area of medical devices, health sciences. When you mentioned the watch, actually, I forgot about that. And I'm wearing another smartwatch as well. I forgot again. Oh, that's another Internet of Things device that I'm wearing.
Exactly.
How prevalent they are and how much around they are. Dominik, if somebody was, say, in first year of one of our courses or perhaps thinking about studying computing, what would you say, what would you recommend to them if they wanted to learn a bit more about this?
I guess looking at the different projects that are out there, I think mainly having some sort of interest. I didn't know that I'm going to end up in a computing stream. And then I looked at my interest, and I was always interested in like mobile phones and how they worked, and even computers as well. And kind of coming up to the decision making of choosing a stream, going into this like rabbit hole of looking at what computers do and where they're used, and they're used everywhere basically, and it kind of got me an interest. I think someone that has a passion for innovation and project making and mainly creativity, anyone who would like to make something new, I think computing has like this whole like range of possibilities. It's like Play-Doh, but it's not really physical. Well, with IoT it is physical, but it's really creative. I think that's the main aspect I like about it.
Yeah, so curiosity, and also like we often talk about computing being a multidisciplinary discipline because it affects pretty much everything else, you know. And we've talked about agriculture and brewing and music and all sorts of stuff, and assistive technology and cars. So IoT kind of gives you an in into a lot of other industries. And the other thing I suppose as well is that, I mean, I never studied IoT. Actually, if I was back in first year, I think I'd love to do it myself because I have deficiencies in my hardware knowledge. And I know I do. My soldering is terrible. I tried to solder a guitar a couple of years ago, fix them. You should have seen the stage, but it was terrible. Anyway, it allows you, if you don't choose IoT, there's nothing to stop you learning it later. So if you've studied computing, you've never studied computing, you want to give it a go, you know, none of this stuff is secret. This is the other thing. It's all open and it's out there.
Yeah,
you know?
That's the great thing about it. I mean, as I said, there's a great community online. And Dominik mentioned a really good thing there. If you want to find out about IoT, have a look at there's some websites out there, maker websites like indestructibles.com and, you know, all these different websites, and people publish the projects they've done.
Yeah.
You know? And then other people, they put instructions and other people can do them, and then they kind of say, I've made this. So you can see the popular ones bubble to the top. And so there's some really interesting stuff that people have done using various different bits and bobs, you know, again, using all the kind of stuff we talked about, Raspberry Pis and stuff, but all those sort of connecting them to all sorts of weird and wonderful things, you know. So it's open. And, you know, you'd even see it in some of the work that goes on with the project work that some of the students here, some of the students that are not on the IoT stream will have aspects of IoT in their assignment work that they do. You know, particularly in final year project, you see it creeping in there because it's accessible and anybody can do it. And you're not ruled out from it. You don't have to study it to do it, you know.
So if you want to find out more about the Internet of Things and the kind of stuff that we do with WIT, go to the WIT website. There's a lot of projects up there and all around it. I mean, I know there's a lot of stuff going on in the Walton Institute as well, the research arm associated with WIT. The lads will be publishing stuff online, publishing various bits and bobs on blogs. As you've mentioned there, what, Indestructibles, is it?
Yeah, there's indestructibles.com, I think is the name of it. But if you look around, even if you go...
Actually, the Raspberry Pi website itself has loads of projects, because we've used loads of them in Coder Dojo, and some of them are involve very simple physical components that you can connect up to it. Sometimes it just needs tinfoil and a bit of wire, you know.
I mean, we created a thing there with marshmallows and I think marshmallows and paper clips. Connect up the Raspberry Pi, and then there's a competition, see, you know, squeezing it to see and it counts the number of squeezes. So you know, it's there's great kind of fun things you can do with it.
Deadly stuff. Well, Dominik, thank you so much for your time today. I wish you all the best in your career at WIT. Unfortunately, there's no marks for appearing on this podcast, but we'll certainly buy you another coffee, okay? And I'll even buy you a biscuit next time as well. Frank, thank you so much for your time. If you want to find out or contact Frank or I'm at Curly Burton Twitter. Frank, I know your profile is on the WIT website.
Correct. You can go onto the website and you'll find me.
Yeah.
Just search me on the website, or even search me online. You'll find the contact details for me there. Yeah.
Awesome. Right, so that's this episode of The Machine. We will be back with another dive into one of the subtopics that we look at inside computer science in the next while. If you have enjoyed this podcast, please leave us a 5-star review on your podcast platform of choice, because I believe the algorithms like that and it helps us. We don't get any money out of it, but we don't do this for money. We do this for love. So, but it would be nice to get some nice notices. And thank you to all our listeners in the States. We've picked up some listeners in Australia as well, so hello to you. And we've also got a pocket of listeners in Wexford, so hello to all the Wexicans. You're very welcome, and you can cross the border into Waterford at any time. You're most welcome. Okay, lads, thanks so much.
No bother at all. Thanks, Rob.